Hello and welcome to the physics pages. Let's solve physics 0625 paper 22 for the February March 2024. Question number 1. A student has a measuring cylinder containing water and also has a balance. Which of these could be used to find the volume of the small metal sphere? She has no other operators. So here we need to remember that to find the volume of the metal piece, we need a measuring cylinder, and that measuring cylinder should be filled with some liquid or water. We need to find the first volume of the water, let's say V1, and then we have to insert the metal piece inside it. Once we have a new volume, this one is V2, the change in the volume will be final volume V2 minus initial volume V1. So for finding the volume, we need a cylinder with water with the metal piece. So option A says that either the measuring cylinder containing water or balance. We don't need balance here. The measuring cylinder containing water only. Yes, we have this one. The balance doesn't require here. Neither the measuring cylinder nor the balance. We need the measuring cylinder, not the balance. So option B is the right option. Number two. The diagram shows a solid object on a flat surface with two forces acting on the object. We can see in the figure, let's say force to the right, I name it F1, and force to the left, I name it F2, which is 3 Newton. What is the resultant force? To find the resultant force, we know that, let's say R or Fr, we add the two forces to find the resultant. If you see, we have a force F1 to the right, I will write it 4 Newton, and I will add it to the force on the left, that is negative 3 Newton, because it is to the left. So when I add them, I get the resultant force is 1 Newton and 1 is positive. It means it's to the right. So we have an option of resultant force should be to the right with 1 Newton value. So option B is our right choice. Number 3. A ball is falling toward the ground, which transfer between energy stores is taken place. Let's say this is the ground and here is a ball. Whenever a ball is at some height, we know that at this position the ball should have potential energy. Once it start moving or falling down due to gravitational pull, the potential energy start decreasing. So we can say potential energy decreases, but as it goes down, its speed increases. Let's say V increases, that enhances its kinetic energy. We know that kinetic energy is directly proportional to the speed. So as it's falling down, total energy remains same, but potential energy converts to kinetic energy. So here we can say it has potential that is going to convert into kinetic. It's not elastic potential, it's gravitational potential energy to kinetic, not this. So part C is gravitational potential energy to kinetic. So kinetic to gravitational is wrong because it was having some height initially. Number 4. Which row contains one scalar quantity and one vector quantity? We know that a scalar quantity has a magnitude only, or size only, or amount only. So any scalar quantity that don't need direction, but the vector quantity should have a magnitude, size, and a direction. Usually, we need to remember at least 4 to 5 scalar and 4 to 5 vector quantities. If we talk about scalars, we should know that very very beginning, from the start, we know that the length, it can be distance, mass, area, time, temperature, speed. All of these quantities are scalar. When we talk about vectors, we should have displacement, it's a vector. We remember acceleration is a vector. We need to remember velocity is a vector. Torque or moment of the force, and all type of forces. It could be weight, it could be tension, or friction. Any type of force is a directional quantity. If you talk about pressure, it's a scalar quantity. So there are a lot. So whenever I would like to find a vector quantity and a scalar quantity, energy is scalar, velocity is vector, mass is scalar, time is scalar, momentum, you can see, is a vector, weight is a vector, distance is scalar, temperature is scalar. So B, C, D are not our requirement. A has a vector, that is velocity, and scalar, that is energy. Number 5. The table gives data about the four liquids W, X, Y, and Z. None of the liquid mixes with any of the other liquids. It means that they have different density. So when you have different densities, the liquid cannot mix. All the liquid are put into the same container and settle to form four separate layers. Which statement is correct? So to understand that, we need to know the density of the each liquid. More denser will settle at the bottom and lighter one will settle at the top. To find densities, we will divide mass by volume. So 10 divided by 10 gives me 1 gram per cubic centimeter. 20 divided by 15, it gives us 1.33 approximately. 30 divided by 50, it gives us 0.6 gram per cubic centimeter. 40 divided by 50 gives us 0.8 gram per cubic centimeter. So if you look at this, the denser one is the X. So if I pour this liquid in a container like this, so the denser one is the X1, So first layer will be X. The second layer of the liquid will be W, top of the X. The third layer will be of Z, and above the Z we can have Y. So at the top is the lightest one, that is Y. Now I'm going to check the options. W forms the layer below X. No, W is above X. It's wrong. X forms the top layer. No. Y forms the top layer. Y forms the bottom layer. No. Y forms the top layer. Z forms a layer below Y. Yes, Z is the second one. Y is the first layer. Question number 6. A weightless beam is balanced on a pivot. We can see this is the pivot. Forces P, Q, and R act at the beam. This is P, this is Q, and this is R. Which equation is correct? This beam is balanced. It means clockwise rotation, that is from R, and Q is balanced by counterclockwise rotation from. So if we see the moment of forces or the torque, so I should start with the first. The torque is always equal to force times the distance from pivot. So P is a force and distance from the pivot is D. So from left side I'm starting P times D. This is counterclockwise. And when I talk about clockwise, it should be balanced by counterclockwise. So I balance it. So Q is clockwise and the distance from the pivot to the Q, this is pivot, it's B. So I can say Q times B plus R times the distance is A. Now if I rearrange from left and right side forces, I can also say P times D. This moves to the left side minus Q times B is equal to R times A. We can write it any of these forms, either clockwise is equal to anti-clockwise or left right. So if you see the first option P times C, I didn't find anything related to C, so this is wrong. P times C, this is wrong. P times D plus Q times B, I have minus here. So P times D plus minus Q times B is equal to R times A. An object is moving at positive 3.0 meter per second. A force acts on the object. After a time, the object is moving at negative 4.0 meter per second. The mass is 5 kg. What is change in momentum? For this object, we can see positive, maybe it was moving to the right. By applying a brake or some opposite force, it start moving to the left. So I just rename them. Initial velocity is u, final velocity is v, mass is m. We are going to find change in momentum, and we know that change in momentum is equal to m times change in velocity. I can also write change in momentum is m times final velocity minus initial velocity. So change in momentum will be 5 kilogram into negative 4 meter per second minus positive 3 meter per second. So this could be 5 times negative 7 meter per second. So it would be negative 35, and the unit is kilogram meter per second. So this is option A, and negative is showing that if it was to the left. Number 8. The diagram shows a column of a liquid that is having a height of 50 centimeter. The pressure due to the liquid at the bottom of the liquid is 6,000 pascals or Newton per meter. So you can see this is the pressure point at the bottom. That is this. Find the density. We know that pressure is equal to density times gravitational acceleration times height. So if I need the density, which is represented by the symbol rho, will be pressure divided by gravity times the height. Pressure here 6,000, and the unit is Newton per square meter. Gravity is 9.8 Newton per kilogram, and the last thing is height, that is 50 centimeter. I need to convert into meters, so I will write 50 divided by 100 meters. So this I got. Yeah. When I simplify this one, it's approximately 1200. That's the option B. Which statement correctly describes a change of state? Change of state is, for example, we have ice cube that is solid, that takes heat or energy and converts into liquid. Change of state is, we have liquid, after heating it, it converts into vapors, that is gaseous, or from gas to liquid by cooling it, or liquid to, so from gas to liquid, this process is called condensation. From liquid to gas, it is called evaporation. From solid to liquid, it's called melting, and from liquid to solid, it's called solidification, or in the case of ice, it's freezing. Now, a gas condenses to form a liquid. Yes, gas condenses to form a liquid, it's true. A liquid melts. No, a solid melts. So this is a wrong statement. A solid cannot condense. Gas condenses. A solid boils to form a gas. No, liquid boils to form a gas. So option A is the correct option. Number 10. The diagram shows a pan used for cooking food. We can see this is the pan, and for cooking, the base of the pan should be a very good conductor, and the handle should be a poor conductor. Why? Because we need to hold it from the handle, and base should need to uh, conduct the heat. Which row is correct for the materials used to make the base of the pan and handle of the pan? As I told you, the base of the pan should be having a good conductor, thermal conductor, and handle should be a poor. So good conductor for the base and poor thermal conductor for the handle. B option. Number 11. Solar heating panels consist of pipe carrying water that absorbs radiation from the sun. To absorb the radiation, we need to have a dark color. More darker the color, more absorption. More brighter the color, more reflection. Which texture and color, as I told you, it should be the dark, is the surface of the pipes so that the temperature of the water rises at the quickest rate. Dull black, dull white, shiny black, shiny white. So it should be black. So must be quickest when it is dull black. When pollen grain in a water is viewed through a microscope, they are seen to be in continuous, rapid, and random motion. We call it Brownian movement. If this is the liquid, we can see the can be like this zigzag path. What causes a pollen grain to move in this way? Convection current doesn't affect bombardment by a single molecule. There is a bombardment, but from all the molecules of the water, because some molecule uh, having hard atomic surface, so they need to pass through the gaps or empty space. So even bombardment on the different side by the water molecule. Yes, this is the better collision with the another pollen grains. So there is a collision chance when there are many pollen grains, but most probably uneven bombardment is the best choice. Number 13. A circular flat bottomed dish contains 100 cubic centimeter of water. Students are asked how to increase the rate at which the water evaporates. So suggestions are listed. Student 1 says pour the water into a flat bottom dish for large diameter. So it is true because if this is a dish and this is a dish, so this will have more evaporation easier if the surface area is more. Cool the dish and water. We know that evaporation can occur at any temperature. So it means evaporation does not depend on the temperature. Does not depend on the temperature of the liquid. Third, create a current of air over the dish. Yes, if there is more air, more current of air, the evaporation will be high. So for me, we need to have more surface area and create more air around it. So option C, 1 and 3 only are. Number 14. Matter consists of very small particles in a continual state of motion. We know that. Which row describes the behavior particle in the liquid? We know that whenever we have solid, so it has strong force between the molecules, but the molecules are confined, there is no gap, only we can have a vibration between them. When it comes to liquid, the force is still strong, but during their motion they change their place. Here no change in place, here they change the places. And in gases, molecules have weak force between them and they can move randomly in all this. So here we are going to talk about liquid. So liquid has a rather strong force. Yes, they move randomly. No, the gases can move randomly, but they can change the position only. Number 15, we have the diagram that shows the equipment used in an experiment on heating of aluminum. This is aluminum block and there is a heater and this is a thermometer to check the heat. The table gives the result of the experiment. Mass is given, voltmeter, ammeter readings are given, and the time is given. The specific heat capacity of aluminum is 900 joule per kilogram. What is the maximum possible temperature rise? We know that heat energy is equal to mass times specific heat times change in temperature or increase in temperature. So increase in temperature here is energy divided by mass times specific heat. But thermal energy, we know that, is always equal to current times voltage times the time over mass times the specific heat. So when I substitute these values, I have current of 5 ampere, voltage 12, time is 300 second, over mass is zero point 0.8 times the specific heat is 900. On dividing all of this, I can get 25 degrees Celsius is the rise in temperature. Number 16, the diagram shows a wave. Y-axis is showing the displacement from the undisturbed position. So this is rest position, and this is the maximum height attained. So from here till here at the top is the amplitude, or from here till here is the amplitude. So P is showing two times the amplitude because amplitude is only one, but R is showing amplitude only. When we start from this rest position, take a trough and a crest. So Q is showing wavelength, that is shown by the lambda, and S is only one crest, so that is half of the wavelength. Which dimensions describe the properties of the wave? So P is amplitude, no, it is double the amplitude, so wrong. P is speed, no, P is double the amplitude, it's still wrong. R is amplitude, yes, R is amplitude. Q is wavelength, yes, Q is wavelength. R amplitude, S wavelength, no, it is wrong. So our C option is correct. Number 17. Which row describes some characteristics of an image formed by the plane mirror? We know that plane mirror forms a virtual upright image with same distance from the mirror but literally inverted. It means left will change into right, right will change into left. But head will remain head and foot will remain foot. There will be no change. So head at the top, foot at the bottom. That's why I said upright. So here are some characteristics. Image is real? No, no, it's virtual. Diminish means smaller, and same size. I told you it's always same in size. Number 18, the range of audible frequency of the elephants is 10 hertz to 12,000 hertz. Horses is 55 hertz to 33,000 hertz. Which statement about the range of audible frequency for the healthy human ear? We know that for the human it is from 20 hertz till 20,000 hertz. So it is more than 12,000 but less than 33,000. Our range is not matching sometime minimum audible range or sometime maximum audible range. The human ear can hear all the sound heard by both elephant. No, elephant has the minimum range more and horses have the maximum range more, so it is impossible. The human ear can hear all the sound heard by the elephants. No, human ear cannot hear from 10 to 20, so 10 to 20 hertz is not audible for us. The human ear can hear all the sound heard by the horses. No, it's above 20,000 hertz we cannot hear. So sounds that are greater than about 20,000 hertz we cannot. The human ear can hear all these sounds heard by elephant Cannot hear all the sound heard by the elephant and those by the horses. Yes, this is the correct option. 19. An object is placed in front of a plane mirror. This is a plane mirror, this is the object. The ray diagram shows the reflection of one ray of the light from the object. This is the reflected ray. I told you the plane mirror forms an image equal in distance on the opposite side, and if this is the object, image will be at the same distance somewhere here from where our eye can see that the image is around, the ray is coming from that one. So if you look at the diagram, where does the image form? The image forms rightly at the same distance, and it comes from this one. A is the correct choice. Question number 20. Light refracts as it enters glass from air as shown below. Which expression equal to the refractive index? We know that a refractive index is sine I over sine R or sine theta incident angle. So if you know about incident angle, it is always with the normal. So this is incident angle, this is refracted angle. So refractive index is sine I over sine R. So if you see sine I is actually not theta 1, it's 90 minus theta 1, and sine R is correct, that is theta 2. So I can just say theta 2, and this one is option C. Number 21. Light traveling at a speed of 3 into 10 to the power 8 meter per second strike the surface of the glass block and undergoes refraction as it enters the block. The diagram shows a ray of this light before and after entering. So this is incident angle, this is reflected angle, refracted, sorry. Speed of the light. We know that refractive index has two definitions. One is speed in vacuum over speed in medium, and also it is sine I over sine. So if I combine these two, I can just say that V over C is sine I over, sorry, sine R over sine I. If I move the C here, V is equal to sine R times speed of light in vacuum over sine I. By substituting the values, sine R is 33 degrees times 3 into 10 to the power 8 meter per second over sine of 55 degrees, and it's about 1.99 into 10 to the power 8 meter per second. That goes to 2 into 10 to the power 8 meter per second. Which row about the converging lens and diverging lens is correct? Let us start from A. Always produce inverted image. No, if an object is in between optical center and the principal focus, it can also use as a magnifying glass. It can be upright image. Can focus a parallel beam of light? No, it cannot focus a parallel beam of light. Can be used as magnifying glass? Yes. Do not have principal focus? No. Can be used to correct the short sightedness? No. It is used to correct the long sightedness. Are usually thinner than the converging lens? It can be thinner or thicker. We don't care about. Can produce real and virtual image? Yes, it can. Can be used at short sightedness? Yes. So option D is the correct option. 23. A charged rod X is placed on the balance and another rod Y is brought close to it. Let's say negatively charged. Okay, this is also negatively charged. So here you can see mass is shown here. It means there is something repelling. So something can repel if it has the same, so it is pushed down, the same charge repel each other. So if it is negative charge, the other is also negative charge. If it is positive, the y should be positive. Negative and positive, no. Negative and no, no. Positive and no, no. So option A is the right choice for me. What is the unit of potential difference? Potential difference is also called voltage, and volt is the unit. It's easier question. The diagram shows a transformer that can step up or step down. Our simple transformer example is the mobile chargers. What is the output voltage? This is V in, this is V out, this is number of turn or in primary, so I can say input voltage as the primary voltage. Number of turn in secondary, I can say output voltage as secondary voltage as well. So we know that Ns over Np is equal to Vs over Vp, secondary or primary voltage. We need secondary voltage Vs, so I can say Ns times Vp over Np because I move this one up. So here number of turn in secondary is 115, primary voltage 22,000 volts over 550. So I got 4,600 volts. Question 26. The diagram shows two arrangements of the pair of the identical bar magnets. Diagram 1, there is north and north pole. So north pole and north pole has this kind of magnetic field because there is repulsion, no attraction always. So this is no field zone. P is having no field zone. But here we can see this is the north to south. Field lines are from north to south. So which point PQR are shown, at which point the magnetic field due to the magnet's weakest and which point are strongest. So P has no magnetic field. From Q and R, at Q there is a large gap between these lines, so it is weaker than R because they are close. So when magnetic field lines are closer, so R is the strongest magnetic field point, whereas P is the weakest. So weakest point is P, yes it is P, but strongest is R, not Q. So our option P is the right choice. A nichrome wire P has a length 1 meter and diameter 1 meter. Second wire Q has a length 2 and diameter 2. Which statement correctly compares the resistance Q with P? So resistance of Q, if I start, is equal to, we know that resistivity times length over, here is the number 4, here is pi dq square. So it means length is directly proportional and diameter is inversely proportional. For the P, so it has length 1 and diameter 1, so it can be proportion to 1. But when you have doubled this one, so this portion will go 4 and length goes 2, so this will be 1 over 2. So RQ is 1 half of the RP. So RQ will be 1 half of the P. So this is option P. We can also substitute the values here because we have the length and diameter given here. So if we can use that one, we can also have, let me solve it to that one. Resistance for the P is equal to 4 times resistivity. Length is 1, diameter I will keep it in millimeters, it's okay, 1 square. So the answer is 4 rho over pi. But when I found for the Q, it's 4 times rho into 2 over pi times 2 square. So this will be 4 rho over, uh, 4 rho times 2 over pi times 4. So this will be 1 over 2 and that one will be Rp. So half of the Rp. Number 28, a student have two resistors. One resistor resistance 2 ohm and other resistor 40 kilo ohm mean 40,000 ohm. So which statement is correct when connected in parallel? So when you connect in parallel, we know that their combined resistance or equivalent resistance will be R1 times R2 over R1 plus R2. So this value will be 2 times 40,000 over 2 plus 40,000. So the R can be 80,000 over 80,000 over 40,000 and 2, that is approximately 2.0 ohm, means approximately it's like this. So when you are talking about in series, so you just need to add them. So in series it will be 40,000 ohm plus 2 ohm, so this will be 40,000 and 2 ohm. So in parallel it's 1.9 ohm, no. 2.0 ohm, yes it is. In series 1.9, no. 42, no. So B option is the right option. Which circuit do both lamps light? Let us start with the lamp A. This is positive terminal, this is negative terminal. Conventional current start from positive terminal toward the negative terminal. But when you see this is a semiconductor diode, that is this is P type and this is N type. So positive attached to N type means this is reverse bias. Reverse bias condition diode doesn't work, so there is no current flow here. So no current. When there is no current, it means none of the lamps light up. On this condition, the current starts from here, it reaches here, some part goes from here, some part here, then it reaches at this point, it goes there, and when it reaches here, so this is negative terminal. Negative is connected to the positive and positive is connected to the negative. So this is P type, N type. So again, N type is connected to the positive. It's the same condition. So there will be no current, no light up. Here in this condition, diode is attached. P type is positive. So diode is forward bias. So it is working and current flows through it like this. So when current flows through it, it means current completes loop in both of these circuits and it will light up. When you move until here, this one, the current starts from here, it completes the circuit from here, from positive to negative, but from the other loop, it is P type attached with the positive with the N type, that is reverse bias. So this loop doesn't work. So this is not light up, this light up, but we need to talk about both working conditions. So both working are in C. An isotope of strontium has a nuclide notation 38. So atomic number is 38, mean number of proton 38, number of electron 38, proton and electron 38. Number of neutron we will find by finding mass number minus this. So 84 minus 38, it gives me 46 number of neutron. So proton 38, neutron 46. So we have this option. A student investigating the count rate of radioactive substance. Whenever we have a count rate, we also have a count rate with the background radiation. So how must the adjust his reading for the background count? he should subtract the background count from the reading to get the accurate reading. What occurs during the nuclear fusion? Fusion means fusing. There are two light nuclei joined together and they emit energy. A lot of energy in the fusion reaction is obtained. 33. A beta particle enters to the uniform magnetic field directed into the page and deflects downward. The cross is showing into the page and it's going down the page. Which direction electric field would also deflect the electron downward? We know that if this is a positive plate, this is negative plate, so electric field will be from positive to negative. If an electron enters from here, it will not go straight, it will deflect down toward the positive plate. So electric field direction is toward the top of the page or up of the page, so option D is the right choice. The radioactive isotope radon 8622 is an alpha emitter. So alpha emitter means helium nuclei is emitted, that is 2He4. During the radioactive decay, isotope of polonium Po is produced. So how many electron does nucleus of the isotope polonium contain? So we need to find number of electrons the polonium should have. Isotope of polonium. How many neutrons? Sorry, my mistake. How many neutrons? So when this alpha emits, the polonium will have 86 minus 2, 84 proton and 218 because 222 minus 4 218. So number of neutron can be obtained 218 minus 84. This will give us number of neutrons. So that will be having 4 21 minus 8. So that is 134. This is option C. Which statement safety precaution can take when a person is working with ionization radiation? He should decrease the time of exposure. Yes. Decrease the distance. No, he should have decrease the exposure time and increase the distance between the person and source. Increase exposure time. So option B is the which list correctly shows the planet in the decreasing order of distance. If we talk about the order of distance from the sun, so if this is the sun, so which one is closer? It is the first one closer is Mercury, then Venus, Earth, Mars. This is Mercury, this is Mars, Jupiter, Saturn, Uranus, and Neptune. So, starting from Mercury, it is the closest. So, here we are going to find decreasing order, means from here to here. If you see Jupiter, this is Jupiter, then Saturn, it's increasing the distance. Jupiter, then Saturn, increasing the distance. Neptune to Uranus, then Saturn, then Jupiter. Yes, it is order is decreasing. Uranus, Neptune, order is wrong. So C option is the correct. The sun radiates most of its energy in three regions of electromagnetic spectrum. Region 1 is infrared, region 2 is visible region, region 3 is ultraviolet region. The diagram shows the comet moving in an elliptical path around the sun, in which position the comet moving with the greater speed. As the distance of the comet is more, the speed becomes slow. So here D is the slowest and A is the quickest. So faster speed is A. Nuclear reactions in a sun release a large quantity of energy. So nuclear reaction in the sun is actually fusion reaction when hydrogen is combining to form the helium. So it involves fusion reaction and it is producing helium from hydrogen. The last question is the table gives data about the planet of our solar system, Uranus, Earth, planet. As the distance moves, the temperature decreases. What are the planet X and Y? We know that planet X is a little bit closer and Y is farther. From the Earth, if we see the closest to the Earth is Mars, then Jupiter, then Saturn. So option A shows that X is closer to Earth. That's why it has temperature little bit more than that. So this option looks good. Mars and Neptune. Neptune is very far. So because Uranus is in between them, so Neptune should have lesser than negative 195, so this is impossible. Mercury is closer to the sun, so it should have more temperature, not less temperature. Mercury less. So for me, option A is correct.